So now we're going to talk about loop idioms. And loop idioms are patterns that have to do with how we construct loops. We have the mechanics of fors and whiles, but ultimately we want to get something done. We want to solve a problem with a loop. And often what we have to do is, if we have a set of things, whether it's lines or strings or characters or numbers, we're looking for something like the largest or the smallest, or we want to add them up or something like that. And so we can't just say add them up. We have to say go through each one and do something to each one and somehow achieve adding them up. And the pattern that we're going to follow is we're going to have this loop that's going to do run once for each thing, right, in some chunk of data. And then, but we're going to set something at the beginning, and then we're going to do something to each one, and at the end we're going to kind of get the payoff. We're going to get the result. So if we're doing sort of summing things, we're going to have a running total, and so this will be like t equals 0, and then this will be t equals t plus the thing value. And then, but this is not the real total, it's the running total during the loop, but at the end it is the real total. And so we're gonna look at what you do at before the loop starts, during the loop, and then what you get after the loop and how you can use that. So we're going to use this loop. It's just going to loop through a set of 6 numbers over and over and over again, right? So we're going to do something before the loop, we're going to do something after the loop, and then we're going to run the loop some number of times. And in this case, thing is our iteration variable because I'm using unmnemonic variables now. So it's going to run 9, 41, 12, 3, 74, and 15. So it's going to run and print these things out. So it runs this loop 6 times, and away we go. Now this loop does nothing except print stuff out. Of course, I like to do that first, is always print things out to make sure that sort of my brain is functioning. So to kind of understand how these loops work, I'm going to ask you to function as a program. And I'm going to show you some numbers in succession, and I want you to mentally figure out what the largest number is, but more importantly, think about how your brain is solving this problem of what is the largest number, given that I'm only going to show them to you one at a time for a little while, and your brain has to do something. And imagine I was going to show you thousands of numbers. I'm not, but imagine I was. How would you organize yourself in a way so that for like an hour and a half you could sit here as I showed you numbers and you keep track of the largest number that you've seen of all the numbers? Okay, so here we go. Here's your first number, second number, third number, fourth number, fifth number, sixth and last number. What was the largest number? What was it? Well, it wasn't too hard. It was 74. But that's not the question. How did your brain arrive at 74? So here's all the numbers. If I'd shown you all the numbers and asked you what's the largest number, your eyes would have sort of gone, and then you got to 74. And you wouldn't do it in any particular order. Your eyes would just like see the 74 and it would just throw smaller numbers away, and it would move really quickly to what the answer is. Even if there was several hundred numbers on the screen, your mind would sort of move fluidly wherever it felt like moving and then arrive at it. And probably what it would do is it would do something like, kind of move like this, find this, and then sort of check to make sure that it's okay, and then say like, okay, I got 74, I'm done. That's not how computers do it. That is not how computers do it. They do not move fluidly. But they are highly dedicated. They're going to do something, 74. But how would you construct a loop to achieve this? So let's take a look. You could create a variable called largest so far. And this is the largest variable, the value that you've seen in the list so far. Now, I haven't shown you any numbers yet, so we'll just set this to -1 to get us started. So now we see 3. And we're like, oh, that's better than -1. It's our first number, so it's probably the largest we've seen so far, right? Great. 41. Oh, that's bigger than the largest we've seen so far, so we'll keep it. 12 is not bigger than 41, so we're not going to keep it. Notice this keeping thing. 9 is not bigger than 41, so there's no point to keeping it. 74 is bigger than 41, so we'll keep it. Is this the largest number? We don't know. We don't know until we're done. 15, not better than 74. So now we're all done, and hooray, 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 we have the largest number. And we had this variable that we kept the largest number that we'd seen up to this point. And then when we know that we're done at the end, then that becomes the largest. So if you look at all the numbers, keeping track of the largest so far, at the end of all the numbers, the largest so far and the largest are the same thing. And so that's how you get this idea of something you're doing during the loop is not really the answer, but by the time the loop is done, you will have the answer. And so here's a bit of code that does this. Use it with our numbers, right? So let's take a look. So I have this variable called largest so far. I set it to -1. Before the loop, remember there's a loop before and a loop after and a loop in the middle. Before it's -1. So now the num, remember underscores are okay, that's my iteration variable. If 9 is greater than largest so far, well largest so far is -1, so that's true, so this code's going to run. So we're going to remember the new number. So this is 9, and so 9 ends up in largest so far, and then we print it out. And so largest so far is 9 after we saw the number 9. Then we do it again. So now 41 comes in. And is 41 greater than 9? The answer is yes it is. So we're going to run this code, copy 41 into 41 into largest so far, and then print it out, and largest so far is 41 after we saw the number 41. Now we're going to run the loop again with 12, okay, and you get the idea, I hope. Is 12 greater than 41, which is the largest we've seen so far? And the answer is no, it is not, so we skip. So the largest so far stays 41 even though we saw 12, meaning we're sort of like ratcheting up, but we never ratchet back down. So we run it again with 3 and 41, and we skip this, and then the largest so far is 41 even though we just saw 3. And now we see 74. Is 74 greater than 41? See, we never are looking at all the numbers. We're only looking at the window on the numbers of the current number that we're looking at. So is 74 greater than 41? The answer is yes. So we run this code and then we capture the 74. So we just saw 74 and it is the largest so far. And then we run it again with 15, but 74 is our largest so far, and so it skips. So 74 remains largest so far after 15, and now we're finished because we just ran the last thing. The for loop takes care of everything and jumps to this print statement and says afterwards, largest so far is 74. But at this point, it's also the largest, right? So largest so far became largest when our loop finished. So that sort of gives you this notion of how we construct, you know, something at the beginning, some kind of thing that we're going to do over and over and over again, and then something at the end. And we put some print statements in just so we can watch it and see what's going on. So coming up next, we're going to talk about some more loop patterns, some counting, totaling, averaging, and finding the smallest number.